Hello everyone. Today we will see organometallic chemistry. This is your chapter number 5 of organic and inorganic chemistry paper of SYBSc student. This is your paper number 4 and the course code is 222. Now what is meant by the organometallic chemistry? So organometallic chemistry is we can study metal and carbon bond formation, which is also called as a organometallic compound. We will study their preparation, structure, bonding and reaction. So what is organometallic compound? Organometallic compounds are the compound which contain the metal and carbon bond, and when we study their properties, their preparation, their structures, that chemistry are called as a organometallic chemistry. The first organometallic compounds was synthesized or was prepared in 1827 by William Gies, and it is called as, that compound is generally known as Gies's salt. The structure of this compound and the name of the compound is potassium trichloroethane platinum 2. Now these compounds are generally a carbonyl complexes. So this carbon is come from the carbon monoxide. These are very important pi acid ligand. This carbon monoxide offers a very good example for forming of a pi bonding in addition to sigma bond with the metal. Generally the metals are used transition metals or inner transition metals. Now before discussing how this metal and carbon bonds are formed or the carbon monoxide pi acid ligands are formed, we should know the electronic configuration of carbon monoxide. So in a carbon monoxide there are total 14 electrons are present, 6 from carbon and 8 from oxygen. So how this, according to the molecular orbital theory, the electronic configuration of carbon monoxides are 6 sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, pi 2px2, pi 2py2, sigma 2px2. So in carbon monoxide there are filled 2p orbitals and there are empty antibonding 2p orbitals. Now we see the structure of carbon monoxide. So in carbon monoxide structure, what we observed, there is a negative charge on carbon. So when this negative charge on carbon, that means here carbon is, as carbon has ability to donate its electron to a ligand when it forms a bond with a ligand, metal carbon bond. So how we can say metal has d orbital. So they have a filled d orbital also and empty d orbital also. Now we see the and carbon monoxide, we just see from their molecular orbital electronic configuration, it has a filled 2p orbital and empty antibonding 2p orbital. Now we see this metal form a bond with carbon monoxide. This metal have empty d orbital, okay, and carbon monoxide have filled 2p orbital. So this electron from 2pz orbital donates to an empty d orbital of a carbon to form a sigma bond. So in this way ligand donates the electron to a metal to form a sigma bond, okay. Then metal have empty d orbital or filled d orbital. So this metal overlap with the anti-bonding orbital of carbon monoxide to form pi bond. So in this way the two-way bondings are formed. Sigma bond is formed due to filled 2p electron transfer to a empty d orbital of metal, and pi bonds are formed. This is also called as a back bonding. Filled d orbital overlap with the empty antibonding orbital of carbon monoxide. So this type of the bondings are formed. Now these bondings are called as a synergic bonding. Now we'll see why these are called as a synergic bonding. So all of you know the sigma bond is formed because empty d orbital of a metal accept the lone pair of electron of filled p2p orbital of carbon monoxide. So ligand to metal bond are formed. Now the pi bond are formed when the filled d orbital of a metal overlap with the empty antibonding 2p orbital of carbon monoxide. So metal to ligand bond form, and this bond are called as a bond formation are called as a back bonding. So what is back bonding actually? Metal to ligand donation of electron to form pi bond called as back bonding. Now why this is called as a Lewis acid or pi acid? Because the ligand which provides empty orbital are called as a Lewis acid because electron pair accept. So these metals are accept the electron pair, and therefore they are called as a Lewis acid, and they are also called as a pi acid. Now we see this synergic bonding. So the mutual reinforcements interaction between the sigma donation from ligand and pi back donation from metal to ligand is called as synergic, and this phenomena is called as a synergism. So this way mutual reinforcements gives the extra stability to carbon monoxide, and which is due to this extra stability the large number of the metal complexes are formed. Now we will see which type of the metal complexes are formed. Generally binary carbonyl complexes are formed. These compounds are formed by transition metals or inner transition metals and carbon monoxide. So these are called as a binary carbonyl complexes. All these are acid pi complexes. So which are the examples? From group 5 vanadium is formed carbon monoxide complexes. Then from group 6 chromium, molybdenum, tungstens are formed. From group 7 this type of the complexes are formed. From group 8, from group 9, from group 10, and many other. These are the some examples which are form a metal and carbon monoxide complexes. These are also called as a pi complexes. Now we'll see synthesis of carbonyl. Now in synthesis of carbonyl there are three methods are popular. Transition metal carbonyls are generally prepared by these three methods. Okay, so which are that method? Direct method, then reductive carbonylization, and photolysis or thermolysis. Now what is in direct method? In this method metal directly reacts with the carbon monoxide under mild condition. So only nickel and iron generally they reacts in this manner to form a nickel carbonyl complex and iron carbonyl complex. When carbon monoxide is passed over impure finely divided nickel between the 50 to 80 degrees Celsius, this nickel carbonyl complex is formed, and when it is heated at 180 degrees Celsius, nickel carbonyl decomposite to give the finely divided nickel complexes. And this principle generally is used in purification of nickel, which is called as the Mons process. When carbonyl monoxide is passed over the metallic iron at 150 degree to 250 degrees Celsius under 200 atmospheric pressure, it gives the iron carbonyl form. Now in the second method, reductive method. In this method, carbon monoxide reacts with metal halide or metal oxide in presence of reducing reagent. Sometimes this carbon monoxide plays a dual role. It acts as a reactant as well as reducing agent. These reactions are often carried out under pressure. In this method, transition metal ions with high oxidation states are generally reduced to zero oxidation state. When lower carbonyl is used is unstable, then it is easily decomposed to the higher carbonyl. Such process is called as a thermolysis process. In photolysis or in thermolysis, sometimes a decomposition of lower carbonyl takes place by photochemical reaction or thermolysis. For example, direct inner carbonyl is formed with this FeCO4 CO by 5. Photolysis will give you further reaction. So these are the very important binary carbonyl compounds. Thank you very much.